All right, let's finish up section 5.5. Hopefully it won't take too long. Let's just review just real briefly what the last thing that we did yesterday, just so that you remember. Oops, I gotta change. Always forget to do that. There we go. What? All right, so what I'm going to do is this. Everybody watch carefully. I'm going to copy and paste. Okay, put that there. So what's true about, let's say, this bottom one? We'll use the same numbers as we did yesterday. We'll do the same exact thing. Right, that's 8 and 5. What? Yes, there's a pencil up here. You can get it. All right, this is 8. And what's this? I copied and pasted. So what's the length of this one right here? That's 5 as well, right, because they're the exact same thing. So what I'm going to do, though, is I am just going to, oops, actually, I'm trying to keep it the same length. I don't know if I hit shift. No, it's not going to work. Anyway, we'll just try to keep it the same length. We'll say it's the same. It might not be exactly, but it's pretty close. Right, so that's 5 as well. All I did was just change the angle of it. Everybody with me? So what do I have? I got a side and a side that are equal. And I have what else? Another side and another side that are equal. But what did I do to the angle? What did I do to this angle and this angle? Are they the same? No, this one's way bigger than this one, correct? So what did our theorem say? They call it the hinge theorem. Do you remember that from yesterday? Okay, that's what they call it in the book. What did I call it? Yeah, side angle side inequality. That's right. So I'll tell you what, let's just do this. Let's connect. Oops, let's try to make sure I hit it. There we go, it's pretty close. I'm going to connect from there to there, and let's do another one. I'm going to connect from here to here. So what did we learn about this yesterday? We learned that if I have two sides that are the same on one triangle as they are on another triangle, is that true here? Do I have an 8 and a 5 here and an 8 and a 5 here? Yes. But on this one, I just changed the angle of the 5. It's still 5. It's still the same length. I just changed the angle of it. So that makes this angle what compared to this angle right here? In comparison, if I compare them, when I compare two things, what am I doing to them? I'm seeing like the lengths of stuff. I'm like one's bigger than the other, one's smaller than the other, or they could be what? Equal to each other, right? So what is this one? I made this one what? Bigger, right? So I purposely made this one bigger than I made this one right here. But the sides are the same, right? The 8 and the 5 are anyway, not the third one. Okay, but the 8 and the 5 are the same as the 8 and the 5 right here, but I just angled this a little differently so that this angle is bigger than this angle. So when you look at something like that and they tell you that this angle, this green angle is bigger than this pink angle, what does that tell you about the third side? That tells you that if this angle is bigger and this one is smaller, what's true about the length of the third side? It's got to be bigger. Let's keep it color coordinated here. Okay, so this one, this side has got to be bigger than this side. So that's bigger. What are we going to call this one? Smaller? It's fine. You understand what we're doing here? So I've got two sides that I did not change the lengths of the sides. I got an 8 and a 5. I got an 8 and a 5. All right? I just changed the angle of that 5. That's all I did. All right? So I got two sides that are the same. So two sides that are the same, but the angle in between is not the same. Okay? One is bigger than the other. So I call this the side angle side what? Inequality. Because they're not equal. They're not congruent triangles. They're non-congruent triangles. This is definitely not the same triangle as this. Okay, but this angle is bigger than this one, so this side is bigger than this one. That's all we're doing. Does that make sense to you? Yes? No?
Yes, sir.
All right, hope so. So let's get rid of some stuff. And yeah, we'll just do this. Let's get rid of all this, get rid of all this. Okay, let's look at it a different way. Now again, just because this is the way the book says, I'm going to put or, they call it the hinge theorem. Why do they call it the hinge theorem? Because of this length right here. Do you see how it's like on a hinge? See how you can go back and forth like this? You could change the angle of it. Yes? All right. Right, that's what a hinge on a door does. Would you agree? Makes it go back and forth like this. Did we change the length of the door? No. What did we do? We just changed the angle of the door, correct? That's why they call it the hinge theorem. All right? If I could keep it the same length. I don't know how to keep that the same length. But anyway, from there to there. Okay, actually, if I hit, let me see something. If I hit R, let's click this. If I hit R, see it doesn't pivot it there. I think there's a way I can make it pivot right there. I just don't want to take the time to figure out how to do that, but you get the idea, okay? That's why they call it the hinge theorem. What we're going to do right now, that we didn't talk about yesterday, is I'm going to say opposite, but that's not the word they use, okay? It's kind of like the opposite of it. So what did our hinge theorem say? Our hinge theorem said, if I have two sides that are equal to two sides, and the angles are different angles, one angle is bigger than the other, that means what? The third side is going to be bigger than this third side, okay? So I've got two equal sides, one unequal angle. The converse, that's a better way in geometry than saying the opposite. The converse of this is this situation. Let's get rid of the word bigger and smaller. What if I didn't tell you anything about the angle? What if I just told you something about the side? What if I told you that this side, I'll put a big S, is bigger than this side? I'll put a little s just to kind of emphasize it. I don't know anything about the angle, right? But I do know that this side is bigger than this side. What do you think you'll be able to say about these two angles right here? Anybody? Are you just not talking to me, or am I losing you? Now watch. What do they tell you? They tell you this is 8 and 5. They tell you that's 8 and 5. And they tell you that this side, this green one, is bigger than the pink one. So what do you think we can conclude from that information about these two opposite angles? If this is a bigger side, then this has to be a what? A bigger angle. Very good. I got somebody on board. All right? Everybody with me? So if I tell you that this is a bigger side than this one, then what does that tell you about this angle right here? This angle has got to be what? Bigger than this angle right here. All right? Let's put some letters in here without me just pointing and making them green and pink and everything else. Let's call this ABC. Let's call this DEF. Make it real easy for us. Okay? So if they tell me that AB and DE are equal, and they are because they're both 8, right? And they tell me that BC and FE are equal, and they are because they're both 5. But they also tell me that AC is bigger, so this is what they tell me. It's given, I'll put. It's given that AC is greater than DF. You understand what they're doing here? They're saying that the length of AC is bigger, okay, than the length of DF. What can you conclude? Then I could say what about the opposite angles? Then angle B must be what compared to angle E? Bigger, that's right. So how do we write that in math, though? We don't say bigger. What do? Put a greater than, right. So angle B must be greater than angle E. That is the kind of stuff that they're going to ask. So they're going to give you triangles on a quiz, on a test, on your homework. They're going to give you a couple triangles. They're going to tell you some information about it, right? So they might say this is 8 and this is 5. This is 8 and this is 5. And then they're going to say this side right here, AC, is greater than this side, DF. Then what we have to do, we have to say something about B and E. Tell me something about B and E. Well, angle B must be greater than or bigger than angle E. That's the kind of question they're going to ask you. Okay? That's the converse of the hinge theorem. So the converse of the hinge theorem, I'll write that. This is what they call it in the book. In this book, they call it the converse of the hinge theorem. Hinge theorem. I'll just shorten that. Or I call it the side, side, side inequality. That's the way a lot of books, okay, at least the books that I've taught out of in the past, okay, they usually call it side, side, side inequality. All right, why? Because two of the sides are equal. You see these two sides right here? Those two sides are equal, but what's true about the third side? It's unequal, okay? So they got two sides that are equal, one side that is unequal to the other side. That means the angle opposite, the bigger one, is going to be bigger than the angle opposite the smaller one. All right, enough of that. Let's do some examples. Maybe it'll make more sense to you. I'm getting a lot of blank stares. That's scaring me a little bit. Don't be scared.
I'm scary.
All right. So draw this. I'm going to copy and paste this. And I'm just going to change, let's see. I want to keep it the same length, so I don't really want to mess with it too much. Let's do that. Come on, there we go. All right. So that's the same length. Because I just copied and pasted it. Just trust me. That's what I did. This is example 4. So this is the next thing. All right, so this is example 4. I just finished doing that converse of the hinge theorem, or the side-side-side inequality. And let's put some stuff in here. Let's K, L. This is M, and this is N. They tell you the length of this one is 7. They tell you the length of this one is 5. They tell you that this and this are equal, and they tell you that these are equal, and there you go. All right, so this is what they give you. So this is what you could see on a quiz or a test or your homework, okay? So make sure you write it down. Make sure you are paying attention, thinking about this, because this is the kind of stuff that you're going to see on a quiz or a test, all right? So they ask you this. They ask you to compare a couple angles, K and L. We'll draw it in there in a second. They're going to compare it. I'm going to put a blank. That's what that little line is right there. It's just a blank. And I'm going to compare it to angle MLN. MLN. So I've got colors here, so let's use some colors to identify these angles. So where is KNL? Take a look at it. There's K, there's N, and there's L. So which angle is KNL? It's that little skinny one down here in the bottom. Okay, that's K and L. Everybody got it? And we're going to compare it. When I say we're going to compare it, what does that mean we're going to compare it? We're going to find out, is that one smaller than the other one? Is it bigger than the other one? Or are they equal to each other? All right, that's what we're trying to do. You got 3 choices. It's a 1 out of 3 chance. All right, you could just guess. All right, it's not, I would rather have 100% odds than having 33% odds, wouldn't you? Right? Yeah, absolutely. So let's not just guess. Let's not just say, oh, on a quiz, I think I got 1 in 3 chances. Let's just guess. No, let's not do that. So what I'm going to do is I want to compare these 2 angles right here, MLN. MLN. That's this angle right here. Everybody see it? So is this one bigger than this angle? Is it smaller than this angle? Or are they equal to each other? Well, how in the world am I supposed to know that? Well, let's take a look. You got 2 triangles. Do you see the 2 triangles? Everybody sees that, right? See this triangle right here? And then you got this triangle down here on the right. Okay? What I want to do is I want to see what they give us on both triangles and where I can go from that. Well, they give me one side is equal to another side. So that's one side. What about this one right here? It's shared by both of them, so that's a second side. What else did they tell me? Did they tell me anything about the angles? No, they're asking about the angles, right? They don't tell me anything about the angles. They don't say that this is a certain amount of degrees and this is a certain amount of degrees, right? They just say, I got to find, is this one bigger or smaller than this one? That's basically what we have to do, all right? But they tell me something else. They tell me that this side right here is what compared to this side right here? Is it bigger, smaller, or equal? What is it? This side right here, KL. It's smaller. It's less than. Very good. It's less than this side right there. So look, I've got one side that's equal. I've got two sides that are equal. I've got a third side that is not equal. So if this is smaller than this, where do we look? I look opposite. If this is smaller than this, then what's true about this yellow angle and the green angle? The yellow angle is going to be what? Bigger, smaller, equal? Smaller. Why is it smaller? Because it's opposite the what? The smaller side. You see that? This angle is opposite the 5. This angle is this angle is opposite the 7. So that means the angle opposite the smaller side has got to be what? Smaller than the angle opposite the bigger side. Yes? You see it? So look, this is smaller. 5 is smaller than 7. Everybody knows that. So the angle opposite the smaller one, which is the yellow one, is smaller than the angle opposite the bigger one. Are those looks because you don't know what I'm doing, or you're just paying good attention? Is that, you're just soaking it in? Okay. All right, so what do we write up here then? This is a blank. I'm comparing. What do I write? It's less than. That's my answer right there. That's my answer. Okay? So K and L, which is this yellow one, and then MLN, which is the green one, the yellow one is smaller than the green one. Why? Why is the yellow one smaller? Just because it looks like it? No, not because it looks like it, because it's opposite the smaller side. This is opposite 5. This is opposite 7. Right? So this angle that's opposite 5 has got to be smaller than this angle that's opposite the bigger side, 7. Yes? Does that make sense? Okay, good. Let's do another one. Did you write this down? I've had this up long enough, right? Okay, so let's do another one. So I'm going to draw a line just straight down like this. This is on YouTube. They're all the lessons that I teach are on YouTube. All right. This. And then, oops. No. All right. It's not exactly the way it looks in the book, but it's pretty close. All right. They tell you that this side and this side are equal to each other. And of course, the one that's shared by both triangles have got to be equal as well. Would you agree? And they tell you, some angles. They tell you that this is 53 degrees, and they tell you this is 37 degrees. Okay? And here's what they're going to ask. They're going to put UV, then they're going to put a blank, and they're going to put VW. So what we have to do, well, we got to put some letters in here first, don't we? That's U, that's V, that's W, and that's X. There we go. Now we're good. So I got to compare those. UV, what does that mean? Is that an angle? That's supposed to be a V. It's not that sharp. But anyway, well, it's even worse. But anyway, that's a UV, and that's VW. So where is UV? Let's do this. Just color code it. Let's make it a little bit thicker. All right. So UV is from here to here. All right. So I want to take that, and then I want to take, and VW. Where's VW? That's from here to here. Okay, those are ones I'm going to compare. The blue one and the green one. It's easier to say in UV and VW, okay? So the blue one and the green one. Now, you might be able to look at it and guess which one's bigger, all right? But you need to know why. Because it may not be drawn to scale on a quiz or a test. This one's pretty close to being drawn to scale, all right? So you can kind of look at it and say, well, the blue one definitely looks bigger than the green one. But is that what you always want to do? No, because sometimes they don't draw them where the big one actually is bigger than the smaller one. So you got to know by the geometry why it's true. So what do we have? I got a side and a side, and then right here I got a side and a side. What do I have that's unequal? I got this angle is what compared to this angle? So bigger, smaller, equal. What is it? When I compare, that's what I'm doing. I'm comparing those. This one, whoops. Man, if I can get my pen working right. Whoa. Let's try it one more time. Let's grab that. Okay, now it should work. This one is bigger than this one. Agreed? So where do we look? We look at the side that's where? Across from that angle. All right? So if this is a bigger angle, then this side has got to be what? A bigger side than this. Oh, where'd my green go? I must have got rid of it. That's okay. Everybody see that? So if this angle is bigger than this angle, then the side opposite the big angle is bigger than the side opposite the small angle. Is it getting a little easier to understand now? All right, so this side has to be bigger than this side. So what do I write up here? UV is what? Greater than VW. Not just because it looks like it in the picture, all right? It's because it's opposite the bigger angle. This is opposite the bigger angle. This one's opposite the smaller angle. So this side has got to be bigger than this side. That's about as straightforward as I can explain it. You got it? Maybe? Okay. Let's see. Got another one to do. It's kind of the same thing, but it's going to introduce a little bit of algebra, right? We've been doing that all year, haven't we? Right? We do things just with numbers, and then what do? They don't make it 8 and 5. What do? They make it 3x plus 2 and 5x minus 7, right? Then you got to solve for x. You got to do all that kind of stuff, all right? So that's what we're going to do right now. This is our last example. Let me just double check. Yep, that's our last example. Now this one, it's a little trickier, all right? So hopefully you've understood what we were doing right there. So let's see. So we got this. We got this. Yeah, that's good right there. And then we got this. All right. And I'm going to, I'm not going to take great pains to make sure that they're equal in length, but I will mark them so that you know what's equal. I should have made that a little bit bigger. Let's try this one more time. Let's go to about right there. And let's go like this. And then let's go like this. That's close enough. All right. And they tell you that this side is equal to this side. They tell you that this side is equal to this side. I'm sorry, this one right here. And they tell you some angles. They tell you that this is 100 degrees. And they tell you that this is 70 degrees. All right? And what I'm going to do, let's make these a different color just so we can refer to them by their colors. I think that's kind of nice to do. And we'll make this, what color do you want that one? Blue? Too late. It's blue. All right. And they tell you one more thing. They tell you that this is 3x minus 1, the green one is, and the blue one is 5 minus x. All right. Doesn't have to be exactly perfect, but as long as you put the 100 where it's supposed to go, the 70 and the two equal things, it doesn't really have to be drawn to scale. It's perfectly fine. So the first part of this is fairly simple, okay? It's not all that difficult. Let's take a look what I have. Now, of course, I don't know the length of this side, do I? Because I don't know what x is. But I do know I got two sides that are equal to two sides. And I have an unequal angle. I've got this angle is bigger than this one. So think about it. I'll give you 15 seconds, okay? Think about the comparison between the green one and the blue one. Right? Remember, 100 is bigger than 70. Excuse me. So I'll let you think about it. I want you to compare this one to this one. Neil, what do you think? Let's compare 3x minus 1 to 5 minus x. Put a blank right there. Is it bigger? Is it smaller? Is it less than? Why is it bigger? Say it, I can't hear you. Exactly. That's a good answer. The 100 is bigger than the 70. Okay? Everybody see that? 100 is bigger than 70. Everybody knows that, right? So where do you look? You look opposite. That means that the side opposite the 100 has got to be bigger than the side opposite the 70. Yes? Somebody nod like you're understanding what I'm saying. Does anybody understand what I'm saying? Okay. Normally, I would love it if you're this quiet, but I'm just not getting much feedback, okay? I like the part that you're quiet and paying attention. That's awesome. But I'm just not sure if I'm getting through or not. So if this is 100 and that's 70, the side opposite the bigger one is bigger than the side opposite the smaller one. So what do I put here? I put greater than, okay? Now what I'm going to do is I'm going to solve for x. Now this is kind of weird because we got a greater than sign. But really, you solve for it just like you would if it was an equal sign. So if it was an equal sign, what would we do? I would get x on the same side, wouldn't I? Right? We've done this. We did it. We took 2-3 weeks doing this kind of stuff. So what am I going to do? Let's take this x and put it over to the left-hand side. How would I move the x over to the left-hand side? It's being subtracted, so we do what? We add it. So I'm going to add an x to this side. So I'm going to add an x to this side. Now, let's move that 1 over to the other side. This is being subtracted, so how do I get rid of that minus 1? I add a 1. So what do I do over here? I add a 1. Right? Pretend this is an equal sign. All right? Just do it the same exact way as if it was an equal sign. So look what happens. That x cancels. This 1 cancels. What am I left with on the left-hand side? 3x plus x. What's that? 4x. Keep the sign, greater than. Add these up. 5 plus 1 is 6. Now what do? We got to get rid of 4 because I want x by itself. How do I get rid of that 4? Divide it by 4. Divide it by 4. Okay, so the 4's cancel. X is greater than. Let's reduce this. Let's not keep it 6 over 4. What does that reduce to? Just a 2? Just plain old 2? Say it. Yeah, I don't want to say it like that. It's actually not 2.5. But reduce it. What goes into both of these? 2. 2 goes into this what? Twice. 2 goes into this 3 times. What is it then? It's 3 over 2. All right? That's part of your answer, okay? What is 3 over 2, by the way? It's 1.5. All right? If you like that better, it's fine. You don't have to. You can keep it 3 over 2. It's perfectly fine. I would keep it just 3 over 2. But that's half your answer. You think, well, why? I just solved for x. All right? Here's something that's kind of weird. All right? I really don't have the best. I can show you how to do it. It's not hard to do. But the explanation that I give is not the greatest explanation. But what I'm going to do is this. We come over here. We saw that x is bigger than 3 over 2. But it must be, again, I need to look up some teacher's explanation to this because I just don't really have a good explanation. But I'll show you what they do. They take this one right here. I think you might be able to do it with both of these. Again, I'm not really sure. I got to look this up. But what I'm going to do is I'm going to take this, the 5 minus x. Now, this is weird, but I'm just going to show it to you. 5 minus x, and I'm going to put greater than 0. Now, would you agree with that, though? Maybe you don't understand why I did it, but would you agree with it? You agree that a length has to be bigger than 0? Yeah, because if it's 0, then it doesn't have any length at all, does it? Okay, if it's negative, it doesn't have any length. The only way for anything to have length is if the length was what? Bigger than 0. Agreed with that? All right. So, again, I apologize for my lack of good explanation of this. But that's what we do. Okay, we take this one right here, we set it greater than 0. All right? And now what we're going to do is we're going to solve for x. All right? So let's do it. I'm going to subtract a 5 from both sides. And then that cancels out. What do I bring down? A minus x. Put greater than negative 5. Now, here's something that should have been taught in Algebra 1, but I can't take that for granted. So I'm going to teach it to you right now. When you're doing algebra with inequalities, almost all the time, except for one exception, and we have that exception right now, without exception, you just do your algebra as if it was an equal sign. Okay? So pretend that was an equal sign. Like right up here, we did all this stuff. If this was an equal sign, we would have had what? X is equal to 3/2, right? Nothing changed. There's only one time where it changes. There's one time where it changes. It's when you divide or multiply by a negative sign. Has anybody heard that in Algebra 1? I think this is a very common Algebra 1 topic, okay? If you divide or multiply by a negative, you need to leave? If you multiply or divide by a negative, okay, you've got to change the sign of your inequality. You never had to worry about that with equals because both sides were equal to each other, right? There was no sign to change it to. But you do have greater than, you got less than. So if I divide by a negative, I've got to change the direction of my inequality. So do we have to divide by a negative? Absolutely, because I got to get rid of this negative. It's like having a negative 1 in front of it. How do I get rid of the negative? I divide by a negative. So I come over here and I divide by a negative, or a negative 1. Now, this is the one exception where you have to change the sign of the inequality. It's when you multiply or divide by a negative. Are we multiplying or dividing by a negative here? Yes, we are. So what do I have to do then? I got to change that from a greater than to a what? To a less than. So that's a little tricky. So what happens here? They cancel out. I have an x. What's this become? Negative 5 divided by negative 1 is positive 5. So I actually get two answers. I know it's weird. I get it. This is the part where I would expect you to be quiet and just say, well, I want to ask a question, but I don't really because I don't want to look dumb or anything like that. Believe me, you won't look dumb if you ask a question about this because I look dumb because I don't have a great explanation for why you do this. All right? I mean, I kind of know in my head, but anyway, you get two answers for this. You have x is greater than 1.5, and you have x is less than 5. So let's just do a number line real quick. This will be the last thing we do. All right? I just want to show you how we're going to write our final answer. We're not really going to write it like I have right here. So let's put, it's greater than 1.5, so let's put 0 right there. Let's put 1 right here. And it goes to 5, so 2, 3, 4, 5. I'll put one more. I'll put a 6 on there. So that's 2, 3, 4, 5. So what does this mean? X could be any number. It's not just one number. It could be a whole bunch of numbers, but those numbers have to be between 1.5 and 5. All right? I could pick any number and it'll make it work. And I'll show you. After we'll pick a couple numbers, throw it back in and see if it really works or not. Okay? So my answer is going to be any number between 1.5. Where's 1.5? Right there. Do you remember when you did this? You did this in algebra, didn't you? Put a little circle there, and then over at 5 you put a little circle, and then what did you do between them? You kind of filled it in between. You remember this, right? That's pre-algebra stuff, right? Algebra 1 for sure. I'm sure you did this stuff before. Okay? So what does this mean? This means that x could be any number between 1.5, we'll just put 1.5, is that all right? 1.5 and what? 5. Look at this. It's kind of weird looking. But x is between. That's how we write in between. Because it's greater than 1.5 and it's less than 5. Do you see it? If I read it from right to left, x is greater than 1.5. And x is also what? Less than 5. So x could be any number in between. Remember what I said we were going to do? Let's do this. So we're going to throw some numbers in here and see if they work. So I'm going to put my answer right up here. There we go. Okay. So let's see if this actually works. What do I mean by it works? Well, this green one should be bigger than this blue one, all right, depending on what value for x I put in. Pick an easy number between 1.5 and 5. A half is between 1.5 and 5. You're just saying things. Are you doing it just to... Hopefully you're not just doing it to irritate me, all right? I hope. So pick a number that's between 1.5 and 5. 2? All right, I heard 2 first. So 2 is between 1.5 and 5. 4 is as well, all right? But let's pick 2. Let's put it in here. If I put a 2 in there, 3 times 2 is what? 6. 6 minus 1 is 5, all right? Let's put that 2 in for this one. 5 minus 2 is what? 3. Is 5 bigger than 3? Yes, it is. Let's do another one that actually works, and then we'll do one that doesn't work, and I'll just show you. So any number between 1.5 and 5 should work. It should make this green one bigger than the blue one, okay? Let's pick another one. Somebody said 4, right? Let's put a 4 in here. So 3 times 4 is 12 minus 1 is 11. Put a 4 in there. 5 minus 4 is 1. Everybody see that? Is 11 bigger than 1? Absolutely. Does it work? Does 4 work? Yeah. Any number between 1.5 and 5 actually works. Now, give me a number that's not between, an easy number, not some crazy number. Give me an easy number that's not between 1.5 and 5. 6. Let's do 6. Okay? Let's get rid of this. Let's get rid of this. All right, let's put 6 in here. 3 times 6 is what? 18. 18 minus 1 is 17. So that looks fine. Looks no problem with that. Let's put a 6 in here, though. 5 minus 6. What's 5 minus 6? That's negative 1. Can I have a length of something that's negative 1? No, I can't. So can I pick a number? Can I pick the number 6 and put it in here, and the bigger one is, this one is bigger than this one? Well, 17 is bigger than negative 1, but can I have a length of negative 1? No, I can't have a length of negative 1. It doesn't make any sense. All right? So that does not work. Let's pick another number that's not between 1.5 and 6. Give me another number, an easy one. 1, that's a good one, okay, because 1 is outside of this. Let's pick a 1. 3 times 1 is 3. 3 minus 1 is 2. Let's pick a 1 here. 5 minus 1. 5 minus 1 is what? 4. Is 2 bigger than 4? No, it's not. Okay, it's a length, but 2 is not bigger than 4. So does 1 work? No. So only the numbers between 1.5 and 5 are the numbers that work. Does that make sense? So that's my answer. Any number between 1.5 and 5 is my answer. So I show all the answers, and that's how I show it. How did I write it again? I put X in the middle, I put a less than and a less than, and I put my 1.5 right there, and I put my 5 right there. That is the way, if it's an odd problem, you look in the back of the book, or if I read it off to you, right, when it's homework time, this is what I'm going to read off to you. All right? I know that's weird. Believe me. I always, even with my honors class, it always bothers me when I teach this because I just don't have a great explanation. Usually, every other topic, I think anyway, I have a pretty good explanation for it. On this one, my explanation is that it works. Making this thing 5 minus x greater than 0, it makes this thing work. Okay, that's the only thing that I could tell you. All right? I know that's crazy. I know it's a little weird, but here it is. It's on YouTube. You could always go back on it, okay, look at it. You could always do some searching on your own. I know nobody's going to do that, but you could, right? There's a ton of math videos out there. People love showing how smart they are and putting their math on there, all right? So you could look up the topic, and maybe they'll give you a good explanation of that as well. Silas? No, I'm going to add to it. It's the second part that I gave you yesterday. What was that? 18 to 25. So now you should be able... My guess is that they only probably have a couple of those type of questions on there, okay? So 18 to 25, add that to the, what did I give you before? 13 to 16. So 18 to 25, and it's section 5.5. All right, so that's your homework. Again, 13 to 16 you should have already had done. Just add it to it. It's not two separate assignments, still one assignment, okay? So it's just 5.5. It's not 5.5a and 5.5b. It's just 5.5. Everybody got that? All right, well, good luck with that. We'll take some questions tomorrow, okay? We'll go over some questions on this tomorrow. I'm sure you'll have a few questions on it.